Very good. So I'm here at the STAR control room getting ready to start a shift as shift leader for this experiment. As you know, safety for Brookhaven is a core value for the lab, and we are very, very concerned about maintaining safe operating environments in all of our laboratories, whether they're large user facilities like the Relativistic Heavy Ion Collider or small laboratory single project investigator laboratory environments. Our new brochure, Safe Conduct of Research, is an important ingredient in making sure that the lab operates in a safe and effective way. I encourage you to look through our new document and use it to develop your own safety procedures for your laboratories that are in compliance with the Brookhaven guidelines. Here are some people from Brookhaven that are implementing the guidelines from our new brochure.
Okay, so I've already donned my lab coat and safety glasses as per typical protocol. I'm going to feed my cells today. They happen to be human neuronal progenitor cells, which can be differentiated into any neural lineages. But first I'm going to put on some gloves. And then I'll come over here to the biosafety cabinet and the hood to perform the procedure. I really enjoy my work here because it's exciting to work with such a diverse community of researchers from other parts of the country and world. And sometimes it's a bit of a challenge because they're used to doing things at their home institution in a particular way, whereas here at Brookhaven we have certain policies and procedures that we adhere to for a good reason. And I like working with them to try to make sure that they think about a different way of doing things while they are here at BNL, and working at the NASA Space Radiation Lab, where we have a beam of charged particle radiation that's the only one in the entire country that can mimic the radiation found in space. So performing the work at Brookhaven is necessary, and we have certain work controls built in that everyone has to adhere to, whether you're an employee or an outside facility user. I'm going to put these back in the incubator.
We are in the laser lab in the instrumentation division. We do a lot of cutting edge science here, and as you know, if you are doing cutting edge science, we also have to have cutting edge safety issues. For example, this is one of our workhorse laser. I may be sending a beam once here, I may be sending the beam over there, I may be sending a beam over there, depending upon what we want to measure. So when I turn the beam around from one place to the other, there may be some scatter light coming in. We have to be really, really careful where this scatter light is going and how we are protecting our eyes from the scatter light. So this laser lab has about 5 people working in there, and each individual knows how dangerous a laser can be and how harmful it can be. It is their own interest, and also obviously they want to protect whoever is coming in there. So it is kind of ingrained in us. When you walk in, we want to make sure we work safely, but at the same time do a cutting edge. So they both go hand in hand. We want, first thing is work safely, second is do the cutting edge. And that kind of a culture is kind of built in the lab.
We're here in the clean room at the Center for Functional Nanomaterials. This is where we're using all sorts of lithographic techniques to make structures on the nanoscale. No matter what you're doing in the clean room, there are some important rules you should always take into consideration. If you're unsure about anything, always ask. Never assume anything or go on your own. Don't improvise. Come ask a staff member. We're here to help you. We're here to answer your questions. Don't ever hesitate to ask. If you're unsure of something, stop. Second, it's important that you take your time when you're working. Nanofabrication takes a while. It's a slow process. You should be aware of that. Don't rush. That's when accidents happen. Always take your time. We instill safety in the CFN clean room through training, through constant communication, whether it be through email or other avenues of communication. We meet and talk with our users regularly and go over any changes that might happen in the clean room to let them know how to work safest in the lab environment.
This is the physics department, the STAR hallway, all the STAR labs, and the remodeled building of part of the building. I've been here for 18 years. A lot of things I noticed with safety within our group is some of them don't understand the English, and they're visitors from all around the world. And I feel if they don't understand me verbalize talking to them, I will email it to them, because on their computer it comes up in their language to better understand. That's important to me. So it's something as easy as that, just understanding not only the employees at the lab, but all the visitors at the lab. And I guess being in the department for so long, you just know if that visitor or that guest is looking at you like you have 3 heads, they don't know what you're talking about, let me put it in wording, and they better understand you, which will help all around. Safety is huge when it comes to science, and can't get the science out of it if nobody's putting their minds together and working safely.
This is the in situ cell that was designed here at BNL under an LDRD project. The purpose of this cell is to study reactions, specifically corrosion reactions of materials as they happen. This is designed for 2 NSLS2 beamlines. Safety was something that we considered from the day one while we were designing this equipment. And so I had my synchrotron research team, I had my materials experts team, and I had my safety team, which had 2 major components, that is pressure safety, for which I was advised by Mike Gaffney and his team. And for the electrical safety, it was Paul Phillipsburg who helped me to ensure the safe electrical design of my instrumentation and controls loop. We took safety as an integral part of the design from day one. We brainstormed various safety aspects, we outlined the criteria, and we ensured that the design met those criteria in order to deliver a safe product.
We are at the XPD beamline, the X-ray powder diffraction beamline, and we're looking at the new robot that's available at the beamline, and we're also looking at some of the equipment that I've supplied for looking at radioactive samples. So this is a sample holder, and this is a sample magazine for radioactive samples. As you can see, the sample magazine can hold up to 20 sample holders. So really the limiting feature is for people to come in and change the samples, and the robot can change the samples obviously much quicker. You don't have to open and close the hutch either. It improves safety because there is no handling of radioactive materials at Brookhaven with these samples, so they're able to do it in their home laboratory where they're already trained and very comfortable with the procedures. So the robot was developed and is used frequently in manufacturing processes, but here it not just increases throughput, but it also improves reliability and improves safety.
So we're looking at a high temperature, high pressure unit used to anneal high temperature superconductors and to overload them with oxygen and change their structure. This unit is capable of going to 100,000 psi and 2,000 degrees Fahrenheit. Realizing very quickly that this was beyond our mechanical expertise and some of our electrical expertise, I went over to the safety department, safety engineering, and consulted with Mike Gaffney and Eugene Santiago. Mike was familiar with the code requirements that would be required for a vessel like this, and Eugene understood the electrical safety.
So being part of the design process from the beginning allowed us to identify potential problems such as pipe hangers, piping runs, containment for the compressor oil, pinch points on the machine itself, and supporting the compressed gas system, which was a separate system which needed to be installed to support the whole system.
Project called the HIP, I find that very personal to me because it was the first project that I was involved in when I came to work here at B&L. I was given a task to come and look at the electrical connections here and see any safety things that I could add to it and see any deficiencies that we might find. Since we have people working in this unit, we also wanted to add another layer of safety as far as when you have to disconnect power to this unit. And that's when we, through design, added the Meltrick system. This allows it to disengage while still in contact and would never give you any exposures. It also allows you to once disconnect and twist and take out, you're allowed to put your lotto lock on there and you are in full control of this now, and it could never be energized while you're working on it.
And it was a perfect example that it's much better to build safety in from the beginning as opposed to have to redesign it after the fact.